Question 4. This one for AB and BC. Let f be a twice-differentiable function on the closed interval -4 to 4 with f of 2 equals 3. The graph of the function f prime, the derivative of f is shown below. Question A. For s greater than 0, the function g is defined by ls minus lns. We need to find g prime of 2. So, we need to check the derivative of g of s, right? So, g prime of s equals f prime of s minus 1 over s, right? So, g prime of 2 is f prime of 2 minus 1 over 2. Now, f prime of 2 is 1.5 right here, right? Which is 3.5 minus 1/2. It's going to be 2 over 2 and it's going to be 1, right? Question B. Find all values of s on the interval 0 to 3 at which the graph of f has a point of inflection. Alright, so the point of inflection occurs when f double prime of s changes sign, right? So we look at the interval from 0 to 3 right here. Alright, so we only have this point right here, right? Observe that f prime changes from increasing to decreasing. In other words, f double prime of s changes from positive to negative, right? F double prime is the slope of f prime, right? So if the tangent lines go this way, the slope is positive. Tangent lines going this way, the slope is negative, right? Question C. For s greater than or equal to -4 less than 4, on what open intervals, if any, is the graph of the function f both increasing and concave down? When it comes to increasing function, f prime must be greater than 0, right? And concave down, f double prime should be less than 0, right? So we look at the graph right here. We need to find the interval where f prime of s greater than 0, right? And f double prime of s less than 0, right? Now you need to be careful. This is the function of f prime, right? So f prime of s greater than 0 when it's above the axis, right? So it's above the axis should be from here to here, right? Now, f double prime of s less than 0. F double prime is the slope of the tangent line of the function f prime, right? So we just draw the tangent line right here, and we see that this guy is positive slope, which is greater than 0, right? F double prime greater than 0. Draw this guy. So we see that this interval right here, f double prime of s less than 0, right? Because the slope is negative. And this guy right here, the slope is positive, right? So the only interval that satisfies this condition is from 1 to 3 only, right? Which is this guy right here, right? It's above the axis, so it's positive, right? And the slope is negative, right? Now let's move on to question D. Question D is considered the most difficult question in this exam. Now, on the interval -4 to 4, find the value of s at which f has an absolute minimum and the value of s at which f has an absolute maximum. Alright, so basically, we look at this one right here, we see that this one is the closed interval. Think about the candidate test, right? First, you need to find the critical numbers, right? So the critical numbers occurs when f prime of s equals 0 or undefined, right? On the interval -4 to 4, f prime of s is 0 when s equals -2 and 3, right? Now we're going to use the candidate test. So we're going to sketch the table as follows. Now we need to take advantage of this guy right here. F of 2 equals 3. Alright, now we're going to use the fundamental theorem of calculus. So we have the integral form -4 to -2 of f prime of s ds equals f of -2 minus f of -4, right? So then f of -4 equals f of -2 subtract the integral from -4 to -2 of f prime of s ds, right? Now we look at the graph, integral from -4 to -2. This guy right here, below the axis, so should be negative, right? So f of -2 subtract a negative number is the same thing as f of -2 add a positive constant a, right? So this guy always greater than f of -2, right? Now the integral from -4 to 4 of f prime of s ds is f of 4 minus f of -4. So f of -4 is f of 4 subtract integral from -4 to 4 of f prime of s ds, right? Which is the net change of this guy add this guy, right? And add this guy, right? And you see that the error above the x-axis always bigger than the error below the axis, right? So this guy always positive, right? So f of -4 equals f of 4 subtract a positive number is always less than f of 4, right? Now from these two guys right here, we can conclude that f of -4 always greater than f of -2 and less than f of 4, right? We need to calculate f of -2, right? So we have the integral from -2 to 2 of f prime of s ds is f of 2 minus f of -2, right? So then f of -2 equals f of 2 subtract integral from -2 to 2 f prime of s ds, right? But f of 2 is 3, right? And the integral from -2 to 2 of f prime of s ds is the error of the region above the axis, right? It's going to be right here. And it's always positive, right? So 3 subtract a positive number is less than 3. At s equals 3. The sign of f prime of s does not change, right? This is still positive and this is still positive. So right at s equals 3, the function f does not have the maximum or minimum, right? At s equals 4, we have the integral from 2 to 4 of f prime of s ds equals f of 4 minus f of 2. And then f of 4 equals f of 2 plus the integral from 2 to 4 of f prime of s ds, right? Now, the integral from 2 to 4 of f prime of s ds, it should be above the x-axis, right? 2 to 4 is right here. So it's always positive, right? Now, f of 2 plus a positive number is always greater than f of 2, right? But f of 2 equals 3, right? So we can conclude that f of 4 always greater than 3, right? Now we're going to make conclusion. We have f of negative 4 right here, always less than f of 4, right? And f of 4 right here, always greater than 3, right? So this guy is the absolute maximum, right? And absolute minimum is right here, because this guy less than 3, right? So at s equal negative 2, right? So we need to make conclusion. The absolute maximum occur at s equal 4. And the absolute minimum occurs at s equal negative 2. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.